question of the day. It's 1751, maximum number of events that can be attended. Okay, so we have been given events, and that is actually in this array right here. You can see. Okay, so you see here we have the events. Okay, and in events, in every events, like this one is the events I is equal to 0. So in this you see this is the starting date and this is the end date of that event, and this is the value that you get by attending that event. Okay, so you have to maximize the value that you can get, and there is also one more limit that you can attend it max, like k event. Okay, so you should not be attending more than k event, and this starting and ending whatever is given, that is purely exclusive. Like if you have attended the events at 2, you can't attend other event which started 2 or anything like that. Okay, so how we are going to do this question? We will first have the two options for each events. Either we will attend that or we can skip that, and if we are not attending that and skipping that, in that case our k is not going to like get reduced. Suppose if I am attending like first event. Okay, if I am attending this event, then my k will reduce by 1 because I have like attended one, so I will reduce 1, so one more event can be attended because k is equal to 2 was that. So either I can attend this one or this one, but you see this event started like 2, but this event ended 2, so this is exclusive, so I can't attend this. So only I have the option to sorry, attend this one. So I can attend this and this, or I can only attend this one. So by attending this one I get the value 1, but if I attend this and this one, I get value 4 plus 3, which is 7. So this will be the correct way to attend to maximize our value. Okay, so at first what we need to do, we have to sort it, because suppose if we have not sorted the events, what will happen? I will have to travel to each event and see which can be traveled again. But if we have sorted, we can use the binary search to get correct events in just log n. That will be like optimized way to travel. So we will first do that. Okay. Now getting the length. Okay. So now let's implement the DFS. Okay, suppose we are starting at the index 0, so currently we have k events to travel, so I will not give 0 right here, I will use index I. Okay, suppose if k is like greater than, so k is less than equal to 0, so what happened in that case? We know we have traveled like k events, so we don't have to travel anymore, we can return 0. And there is more way in which like we will have no choice to go where our index is out of range. Okay, so in that case we will return 0. Okay, now suppose we have the choice to take this one, and we can select other as well. So it is up to us to either take this like index event or to ignore it. So for doing that, we have to return the max value, so we have to compare the values of it. Okay, so either we have to go to the next event, so going to the next event will be this one. Okay, we are incrementing the index and k will remain same because we have not like included that, and if we are taking that, in that case we will first have to take the value of that events. So events I, and the value is at index 2. Okay, and then we have to find out the DFS of some values here. Okay, suppose that will be j, and k will be -1. Okay, so what will be the j, which value, which index I can pass right here? So it will definitely be greater than I, but it will also be the greater than the ending value of our indexed I. So suppose right here it was the starting day, it was the ending day, and this is the value. Okay, so other event that we are going to take will definitely have to have starting index at least greater than our ending days of this event. So for finding that, we'll definitely need one helper function. So let's implement that. Okay, and we are passing, and okay, this, and we are passing. Okay, so that we will be aware of, like, we have to get greater than that value. And firstly we will take the index that is equal to 0, and okay, now let's implement binary search. Middle element we can get by now. This is the index, but we have to find out the starting day of the event. So the index that we have to get the starting index. So for that we will do events m, and its starting days will be at index 0. So if this value is greater than the middle value that we have got, in that case what we will do, we can make right is equal to m minus 1. Okay, else we definitely can make l is equal to m plus 1, and at last the left that we are returning will definitely have the starting index, starting days greater than our index of the first event that we have taken. Okay, so we'll return l right here, and here we have to get the j first, and the j will be helper of e. Okay, now we are done with it. But this DFS that you see, every time there will be lot of duplicates value that we have to calculate. So to avoid that, we can memorize it. So for doing that in Python, that is a easy trick that you can use. Just write cache, and that's it. We have not returned anything yet, so it will keep the none. Let's return right here. Okay, okay, somewhere it's saying it's the wrong answer, so somewhere we have to make difference. Let's see where we can change. Okay, events dot sort. Okay, oh, here it will be e. The mistake, silly mistake, because we have to compare with the ending value of that first event that we had. So that was it. Let's try to submit it. As you can see, this got accepted. That's all. Thank you.